Well, let's see. What are those? Complex numbers. Oh, and by the way, if you want to join me, I'm on page 462. Page 462, we're going to be talking about complex numbers. That means numbers that have an imaginary part, which means not real. Yeah. So I've got some notes already on the board. We've got the standard form of a complex number. This second thing here, this tells you where I comes from. Anytime that you see the square root of -1, that can be replaced with an I. Okay? And then this guy right here, I put him in a box because he's so important. I squared is -1. Go ahead. I said 462. 462. All right, so we're going to start with problem number 3 on page 462. And I'm going to show a lot of detail for this first example, and then after this first problem, from then on, we'll just do shortcuts, okay? But I do want to show you the long way at least once so you can see how it works mathematically, and then after that, we'll do it mathematically. All right, so we've got the square root of -25. I think most of y'all would agree that there's not two numbers that are the same number that multiply to make -25, right? Positive 5 times positive 5 is 25. -5 times -5 is positive. And so you're not going to find two of the same that multiply to make a negative. So here's what we're going to do with this. We're going to rewrite it like that. And you tell me if that's the same thing. Is 25 times -1 the same as -25? Yes. Okay. And then there is a property of radicals that says if I have several factors under a square root, you can give each one of the factors their own square root. And that only works for things that are multiplied. You can separate them up and give them their own square root, okay? So by doing this, what I've been able to do now is break off a piece that we can square root. Square root of 25 is 5. And then we've got square root of -1, which is I. And that's where I comes from. And that's not bad grammar. See if anybody got that one. Everybody get that joke? That's where I comes from. And that's not bad grammar. Okay. Now I've got some good news for you. If you have my calculator, if you have the one I recommended, the Casio FX115ES Plus, if you'll turn it on, that's a good way to start, turn it on, and then hit mode 2. Mode 2. That's complex mode. And now you can type in things like this, like you can tell it square root of -25, and it'll actually give you the I in the answer. If you're not in complex mode, it won't do that for you, but it will if you're in complex mode. Okay? Any questions before I move on to the next one? Yes. Say that again.
How do you say the complex like to put it back?
Oh, how do you put it back?
Yeah.
Mode 1. Mode 1 is like standard computation mode, and mode 2 is if you want to work with complex numbers. Now, I will tell you that it's okay to leave your calculator in complex mode. It won't affect anything else you do on the calculator, okay? It's only going to benefit you. It doesn't have any negative effects. All right, let's try another problem, number 9. And I said from here on we're going to use shortcuts, right? Okay, so let me show you the fast way to deal with this. It turns out anytime you have a negative under a square root, you can just bring that negative out and it'll make an I. Y'all see how easy that is? A negative under a square root, you can bring it out, that'll make an I. Super easy. And then does 98 square root? It doesn't have a perfect square, does it? 98? But can I break it down? Go ahead.
What was in front of a 98?
A negative? It was negative 98. And I'm showing that the negative sign, if it's under a square root, you bring it out and it makes an I. Can y'all come up with two numbers that multiply to make 98, one of which is a perfect square? Okay, good. 49 and 2. 49 times 2 is 98. And the square root of 49 is 7. Do y'all see I'm bringing the 49 out? And in order to bring it out from under the square root, you got to square root it. And so the final answer is 7i square root of 2. Now I'd like to see if the Casio gives the same answer.
It just says 7 square root of
Like so? Okay, so then the question is, are both of those correct? Yes. Because when you've got three things that are lined up like this, it means they're all three multiplied. And does multiplication matter what order you do it in?
No.
No. 2 times 3, 3 times 2, same answer, right? Okay, but I can tell you that this last answer is better because it's closer to being in standard form. Notice in standard form, I is the last thing you write. And so this is closer to standard form. But there is a downside to doing it this way. If you get careless with your square root and you extend it too far, it'll look like the I is under the radical when it really shouldn't be. And so that's why I kind of like this way to do it. This way you know for sure the I is not under the square root. Y'all see what I'm saying? And I think if you're inputting this into My Math Lab, it should take either one. Either one is correct.
Would there be any case where the R would be under the square root?
Not in this class, no.
Okay.
No. I can't think of a time that I've ever seen that myself. All right, anybody have any questions about that? And again, some of you did put it in the calculator and verify that it gives the answer. Okay, so let's try another one. I'm going to just make up a problem and see if you can do it on your own. Bam! Let's see if you can simplify that completely. Square root of negative 250. You already got it? You got it already? What'd you get?
5 square root 10 with I.
Like so?
5i over 10.
Huh?
You got 5i over 10.
5i over 10.
Yeah. Or the
The square root?
yeah.
5i square root of 10. Okay. Yeah, so it turns out that those two answers are both correct. Yeah, and let's show how to get that without a calculator. So remember the negative under the square root. That's where I comes from, right? And did y'all notice that is the first thing you do? So the rules for simplifying radicals are the same as the rules for being in a fight. Y'all know when you get in a fight, the first thing you do, take out the i's. Yes, same for radicals. First thing you do, take out the i's, okay? And then 250, I think, can be written as 25 times 10. And the square root of 25 is 5. So that's how we're going to get that by hand, just in case you need to show work. Go ahead. I can guarantee you on the next test you take, there will be some questions that will say must show work. Yeah.
Does the I, does it matter where it goes, or does it matter where it goes? Because you're putting it in both. Because you're putting it in front and on the calculator.
Right. So the answer is it doesn't matter. So when you take your next test, if one of these is on the test and you write it the way that the calculator shows you, right? Or if you do it by hand and you get the I in front, both of those will be correct. Yeah.
Is there going to be a time where we're going to have to like reverse it? Let's say the question was 5i square root of 10. Would there be a time where we have to reverse it to get square root of negative 20?
No. Do you mean working backwards? You know. That's another one of those things I don't think we've ever done. And the only thing that I think that I should say is, are y'all listening? If they were to ask you what is the value for B, then it would be better to have the I all the way at the back. Because in this problem, the B is the 7 square root of 2. B is all of the numbers that are with the I.
Okay, well, what if it asks for A and you get that answer?
Ah, well
There
then
would be an A?
then A would be 0.
Okay.
Because there's only a coefficient of I, there's no real part. Okay? Y'all ready to do another one? Okay, so let's move on to number 15. Now, number 15 is where we get into working with complex numbers. Now that we've already got the I established, we need to know how to work with complex numbers. And what is the indicated operation here? Addition. Do y'all see that this is a complex number here? Because I've got 12 is the A and 3 is the B. Do y'all see that? This is A plus BI. That's a complex number. And this guy back here, this is another complex number. And I'm trying to add them. It turns out that it's super easy to add complex numbers. All you have to do is combine like terms. So we're going to add the A parts together. 12 plus negative 8. 4. And then we're going to add the B parts together. 3i plus 5i. And that's done. Super easy. Just combine like terms. Now, for those of you that have my calculator, I've got some good news for you. If you put your calculator in complex mode, like I told you, now the button that says E and G, when you push it, it'll make an I. And you can type this into your calculator just the way it looks, with the parentheses and with the I, with the negative 8. You can actually type all of that stuff in, and when you hit equals, it's going to spit out your answer, 4 plus 8i.
And that's the standard form.
And that is the standard form. Yeah, just remember standard form says I has to go last.
So 4 is A, and then B is 8, and
Cor-
I.
Correct. Yeah, so 4 is the real part, and the 8i is the imaginary part. And did anybody type that into the calculator and verify that it did work?
Yes.
Okay, good. I mean, not that you really need to use a calculator on that. That's just pretty easy. But if you just wanted to check, I mean, it doesn't hurt to check. Okay, next problem, number 23. And for number 23, what is the indicated operation? Subtraction. Yeah, this time we're going to subtract complex numbers. But what I want you to notice is that there's a minus in front of a set of parentheses. And so what does that minus really need to do? Yeah, so let's go ahead. Let's distribute the minus. And that'll make that minus 8 and minus 2i. And then all you need to do to finish it is combine like terms. So we're going to have 13 minus 8, which is 5. And we're going to have 9i minus 2i. And we're done. Questions? Anybody have a question for me? Did the calculator do that one as well? Oh, yeah. But again, not that big of a deal, right, with subtraction? You just change the signs and combine like terms? Yeah. Yeah, and that's coming. Guess what's coming next? 45. It's about to get fun.
Oh, come on.
And I know some of you may struggle maybe just a little bit with the signs, and so you want to pay attention to this one, okay? If you're ever having difficulty with figuring out how the signs work, you definitely want to watch this one. Are you ready? Okay, so what is the indicated operation? Multiplication. Yes. There's nothing in between the parentheses. This is going to be multiply. And did you notice that those are both binomials? So what is the technique? Oh yeah, it's the 4-letter F word. The FOIL. We're going to FOIL it. Are you ready? Here we go. First, 8 times negative 2. Positive times a negative. That makes that negative. Do y'all see the signs determine the sign of the outcome? And then on the outside, positive times a negative. 40. And that one's going to have an I. So far, so good? On the inside, negative times a negative. 6. Oh, don't forget the I. 6i. And then last but not least, negative times a negative. Positive. 5 times 3. Oh, look out. I times I. Oh, yeah. Boy, I'm glad I wrote that down. I squared is negative 1. So anytime an I squared shows up, you can take it out and put negative 1 in its place. And let's combine like terms. Yes, Choppa.
So does the I squared, does it change the positive 15 to negative 15, or does it change just the 14?
No, it will. If you take the I squared out, it changes the 15 to negative. Because you're multiplying, that is correct. All right, so here we go. What is negative 40i plus 6i? And that's going to be plus 15, but that is indicated to be multiplied by negative 1. Right? It was 15 times I squared, so now it's 15 times negative 1, which is going to turn that into negative 15, which will go with negative 16 and make negative 31. And this is where people are going to be kind of glad they have the calculator.
What I have problems with is the simplifying, like 79 through 88. I don't know why.
79 through 88? Hey, we can look at that too.
I don't want to.
Yes, you do. Okay, I got another one to do. Are y'all ready? Okay, so that was 45. Number 65. There we go. And this will cover all of the operations. We did add, subtract, we just did multiply, and this is divide. Fraction bar means to divide. It turns out that it's not okay to have I in the denominator. Because if you remember, I by itself means square root of -1, which indicates a square root in the bottom, which is definitely not allowed. So we're going to look at how do we get the I out of the bottom. Well, it turns out that you have to multiply by the complex conjugate. Take that. So the complex conjugate is the same denominator with a different sign. Oh, that's right. Whatever you do to the bottom, you got to do to the top. So we're going to have to multiply top and bottom by 5 plus 11i. What did I call it?
Yes.
I called it the complex conjugate. Anybody need me to write that down?
Yes, please.
I will.
Wait, what was the original denominator?
The original denominator was 5 minus 11i. That is a sexy term. Complex conjugate. Yeah, that's this guy right here. Now the numerator is easy. In the top, we're just going to distribute. So that's going to give me 15 plus 33i. That's the easy part. Guess what we're going to get to do in the bottom? FOIL. Oh yeah, curses. FOIL again. Here we go. 5 times 5. On the outside. Plus 55i. On the inside. And last but not least, negative 121. I squared. Because that one has an I times an I. We get an I squared. Everybody follow me there? Doing the FOIL method? Oh, what do you see? Yeah, so look at my 55 I's. Now you see them? Now you don't. That is correct. And so some of y'all have found another shortcut. Right? Anytime you see an I squared show up, you erase it and change the sign. Did y'all see that? You see an I squared, you cancel it, change the sign. Okay, so what does that give me? That gives me 15 plus 33i over 25 plus 121, which is 146. So the final answer is 15 over 146 plus 33 over 146 I. That's the final answer.
You can't put it over here, like that on top of 146 on the bottom.
You mean it's like one fraction? Yeah, you don't want to leave it like that.
Okay.
And I'll explain why, okay? Are you ready? I'm about to explain why you want to separate it. If we go back up to the top, do y'all see standard form is two separate terms? So if it says write your answer in standard form, then you have to be able to see the A and the BI. A plus BI. That's why you need to separate it.
All the answers should be in standard form.
On the test, it's always going to ask for standard form. Right.
So might as well just go ahead and
Might as well just go ahead and get used to it, yeah. Hey, and guess what the calculator does for you? It even puts it in standard form, doesn't it? Did anybody type that one into the calculator the way it looked at the beginning? Yeah, you always want to type those problems in the way they looked at the beginning. So 3 over 5 minus 11i. And if you hit equals, it does all the work for you. Technology. Yeah. Anybody have any questions so far? All right, now we're going to cover some problems just for Candace. Here we go, just for you. 79. And in these problems that we're about to do, we're going to simplify higher powers of I. That's what it's called. It's called simplifying powers of I. So here we have I to the 11th power. And we want to simplify that expression. Now, if you type that into your calculator, does it give you a simplified answer? Or does it give you an error message? What is it? If you say I to the 11th power.
It gives error.
Error?
So you can't.
Also, the calculator doesn't do everything for you. Yeah. All right. So let's look at how this works manually. Are you ready?
Yeah.
I'm going to show you the easiest way I know. What you want to do is you want to take that exponent and divide it by 4. You want to take the exponent and divide by 4. Every time. So what do you divide by every time? 4, sure. For sure, you divide by 4. So 4 goes into 11 2 times. 4 times 2 is 8. Remainder of 3, right? What do you got, Nicholas?
Where did you get the 4 from?
It's a rule.
It's a rule that I'm using her answer. It's a rule. Where did I get the 4 from? Because you always use 4 when you're doing powers of I.
Oh, okay.
I hate to use that answer, but sometimes you just got to say,
Yeah.
because I said so. Right? All right, so let's explain though why 4. Okay, I can at least tell you why 4. It turns out that once you get this remainder, you're going to take this remainder to the chart that I'm about to give you. There's a chart. I to the 0, I to the 1, I to the 2, and I to the 3. It turns out that there are 4 values that a power of I can be. There's 4 outcomes that it can be. Okay, so first of all, I to the 0. What is anything to the 0 power? No. 1. Anything to the 0 power is 1. That's a math rule. Anything to the 0 power is 1. Okay, what is I to the 1? What's anything to the first power? Itself. Anything to the, like 3 to the first power is not 1, it's 3. 5 to the first power 5. So anything to the first power is itself. What about I squared? We covered that earlier, right? I squared is negative 1. And I to the third is negative I. And then if you go to I to the fourth, the pattern repeats. So I to the fourth would be 1. I to the fifth would be I to the sixth would be negative 1. I to the seventh would be negative I. Y'all see what I'm saying? After the third power, the pattern repeats.
So who made that up? Like what's the, I guess, equation to figure that part out?
That's a good question. That sounds like a research paper. Yeah. No. Thanks for asking though. Anybody else have a question?
So the 11th power would equal 1.
I'm sorry, what?
The 11th power to I would equal 1.
No, I to the 11th power is going to equal negative I.
Oh, yeah.
Because the remainder corresponds to the exponent. So you definitely want to have this chart, well, either memorized or maybe put it on a little card and put it in your wallet or purse so that you always have it. I have one of these in my wallet that I carry with me everywhere.
You should laminate it for us and hand it out to everybody.
You know,
Or
I'll
sell
let you
it
do that.
So you can make some money.
Huh?
Sell it for
Make
like
it and sell it.
I'm not interested in
$10.
making money. No.
You make that.
No.
Yeah.
So if there wasn't a remainder, it would be 1.
If there wasn't a remainder, if it divides evenly, it would be 1. Yeah. Okay, so I've thought about it a minute, and I really do want to give y'all the best answer I can. As far as y'all are asking me, where did this come from? How did whoever come up with this or whatever? Well, the first one is by definition, anything to the 0 power is 1. So that one is taken care of by definition, okay? The next one is also taken care of because anything to the first power is itself. So that one is automatically taken care of again by definition. And then if you remember what I is equal to, isn't I equal to the square root of negative 1, right? And so if I square one side, I have to square the other. But we know a square and a square root cancel each other out. And so that's where we get I squared is negative 1 from. So far, so good?
Yeah.
Okay, now let me show you where I to the third comes from. Would you agree that I can rewrite I to the third as I times I squared? Right? Because if I multiply x times x squared, I get x to the third. So I times I squared is I to the third, okay? But do I know what I squared is? Okay, so that's going to be I times negative 1. But negative 1 times anything is, well, negative that thing, right? And so that is how we get that one. Now that shows you how we get the chart, right? Now, if I keep going, I to the fourth, would you agree that I can rewrite I to the fourth as I squared times I squared?
So it'd be -1 times -1, which equals 12.
Negative 1 times negative 1 equals 1, and that gets us back to the first one. Do y'all see that? So I can, and this, taking a high power and breaking it down into these other powers, that's the long way. Doing this division, that's the shortcut. But at least now I've kind of shown you where the chart comes from. So let's do another one. Let's do number 83. that to the 64th power. And y'all are sure the calculator won't do that? If you type in I to the 64, it's not going to spit out. What does it give? An error message? I'm sorry. Okay, so you gotta kind of know how to do this one. Now, what did I say to do? I said take the exponent and divide by what? Always 4? Would Desmos do this? I don't know. You want to check? Let's do this. Let's finish this one by hand and we'll go to Desmos and check. I don't think I've ever tried it in Desmos. All right, so how many times does 4 go into 6? Wait, 4 goes into 6 one time. 4. Remainder of 2. Bring down the 4. 4 goes into 24. 6. 4 times 6 is 24. Remainder of 0. Oh, it goes remainder of 0. And so that means I to the 64 is 1 because the remainder corresponds to the exponent. So remainder of 0 means I to the 0, which is 1. Do y'all see how that works now? The remainder corresponds to the exponent in the chart.
Okay, this is better than how I was taught originally.
Oh, good. Because this is the easiest way I know of to do these problems. Now, let's go to Desmos and see. Have a nice day. Let's see. Desmos. I to the, what did we say, 64? No, I don't want to add a slider. I want you to work it out. No, that's if it's a slider.
Is it like a type of I that's like a keyboard on this one?
Oh, there's an I. Let's see if it'll do just I squared. Why is it saying 6.25? Oh, no. Here's why. It's because I've established I as a slider. That means I is like X. Instead of the complex I, Desmos is seeing it as variable I. And right now I have I set to be 2.5. So 2.5 squared is 6.25. So that's what Desmos is doing. So the answer is no. No, Desmos is not going to handle your complex numbers.
You can't change the settings on it.
Nope. Unfortunately, this Desmos is set to graph in the real coordinate system. X comma Y, right? Not real comma imaginary. So it's unfortunately not going to do it. I wonder if there is anything that will do that.
So is it called imaginary because it doesn't graph?
Is it called imaginary because it doesn't exist in the real world? Like you can't graph it on a XY coordinate system. It just doesn't exist. But now they do have a complex plane where the x-axis is the real number and the y-axis is the imaginary. And you can plot points like that. 1 second. Let me check real quick. I just want to see if we can find a tool. Anybody ever used Mathway before?
No.
You've seen it before? All right, so let's see if Mathway will do it. Oh, look, here's an I. Oh, look at that. Do y'all see that?
Yeah, it does it.
I squared is, okay, so what about I
It's 64.
to the 64? What should that be? What do we get? 1. Oh, snap. Yeah, so there's a tool that'll check your work, okay? Mathway is doing it. I know, did I mention that Mathway is also an app you can download to your phone? Yeah, okay. I tell you what, I'm lazy enough that if there's a tool that exists, I'll find it to save me from doing handwritten work. And y'all do understand that I'm introducing you to these tools not as a way to do your work, but as a way to check your work. Because I told you, right? Who was it that asked me? Was it Giselle or Chapa? That said, one of y'all asked me if you were ever going to have to show work. It was you, and I said on the next test, I'm definitely going to have problems that say must show work. Yeah. And I'm done with that section. And what time? This class ends at 4:30, so I'm going to keep going.
Well, I have a question.
I'm sorry, what's your question?
You didn't do like the negative I to the 71. Are we gonna have anything like that? Like number 85 or 86? Or even
Yeah.
87 or 88?
No, we can do those. Let's do 86. Are you ready? Are you ready? All right, so let's look at negative I to the 6th, okay? And I'll show you that this is nothing, okay? It's gravy. First of all, if you have a negative anything to an even power, what is that going to become? Negative to an even power. Positive. A negative whatever to an even power becomes positive. And a negative raised to an odd exponent will always be negative. Y'all agree with that, right? What's a negative times a negative? Well, what if I do another negative times a negative? Positive? Well, what's a positive times a positive? Positive. So do you see if I have an even number of negatives, it's going to come out positive. Whether it's 2 negatives make a positive, or 4 negatives make a positive, or 6 negatives, or 8, a negative whatever raised to a, what did I say, even exponent comes out positive. So negative I to the 6th is the same as I to the 6th. Negative I to the 6th is the same as just I to the 6th. And then you just work it as you normally would. Yeah, you divide by 4. So what if I have negative I to the 17th power? So a negative to an odd power becomes negative. And so then you're going to figure out I to the 17th the way we just showed you how to do that. And the answer is going to be negative. Yeah, so let's do it. What is 17 divided by 4? Well, 4 times 4 is 16, remainder of 1. Right? And remainder of 1 corresponds to I to the, why did I write I to the I? I got carried away. Have a nice day. So remainder of 1 corresponds to I to the 1, which is I, and the negative out front makes it negative.
If you ended up with like a negative 1.
Then you say minus a negative makes it a positive. And you'd end up with positive 1. Yeah, so those are not bad. What's up?
Will the exponent ever be negative?
It could be.
What if it's negative?
Okay, y'all are doing the what if game today. I like it. What if? So let's call this example T. I don't know where that came from. We'll just call it example T, okay? And you said, does it matter what it is? You want to make it up?
Just whatever is whatever negative.
What, like I to the negative 9? Okay, so it turns out that we can make that entire problem into a fraction, right? I can make anything into a fraction by putting it over 1. And it turns out that negative exponents are not happy. They want to be positive. So if they're unhappy in the top, they want to move to the bottom. So now there's nothing left in the top, and now the 9 is positive.
But imaginary number doesn't like being in the
Right. But the first thing we need to do is simplify this and see if it still is an I and then fix it. Okay? So then we're going to take the 9 to the side and divide it. Okay, 4 goes into 9 2 times. 4 times 2 is 8. Remainder of 1, which corresponds to I to the 1, which is I. Okay? But remember we said that we don't allow I to be in the bottom. So we're going to multiply top and bottom by I. So in the top, we're going to get I. In the bottom, we're going to get I squared, which is negative 1. And I divided by negative 1 is negative I. And so we can take that and simplify it. What up, Tim?
How do you flip?
Like here? Now, the reason that it appears to have flipped, I didn't really flip it, it appears to have flipped. I simply took the I to the negative 9 and I moved that to the bottom. Now, there is an understood 1 in the top, right? Because 1 times anything is itself. And if I move this to the bottom, that 1 is still there. But also, if I move the I to the 9 to the bottom, the 1 that is there is going to get multiplied by I to the 9. But 1 times anything is itself, so I don't really need that 1. And then I take this and work it. Now that works for any variable with a negative exponent. Any letter with a negative power, you're going to move it to the bottom to make it positive. And then you're going to simplify it. And then if it still leaves you an I in the bottom, you need to fix it. This is looking like a real good test question. Thanks. Thanks, Cassidy. I appreciate that. Anybody else want to play the what if game?
Well, what about one 87 or 88? Because it has the number in front of the I.
Which one do you want to do?
Which one's easier?
I don't know. Let's look at 87. We'll look at 87. 5i to the 4th. And we're going to use our math powers, okay? We know all the laws of math, don't we? Yes, we do. We know all the laws of math. What does it mean? What does it mean to raise something to the 4th power? So doesn't that mean 5i times 5i times 5i? Isn't that what that means? But isn't the 5 and the I also multiplied? So I can go back and I can insert multiplication in between the 5 and the I. And do you see that everything is multiplied?
So what would be 625 I to the 4th power?
Yeah, so my question is, when you're multiplying a bunch of junk, does it matter what order you do it in? So could I regroup it and say 5 times 5 times 5 times 5 times I times I times I times I? Could I regroup it like that? Yeah, and so what that really means, it means I've got 5 to the 4th power and I to the 4th power. So in other words, this exponent can distribute and become the exponent on each factor. And then you can evaluate 5 to the 4th. What is that, 625? And then you can work out I to the 4th. So we're going to divide 4 divided by 4. 1, 4. Hey, remainder of 0. What does that mean? 1. 625 times 1. Which is 625. Piece of cake. And I don't know if y'all noticed how crazy that last one was, but we started with something that doesn't exist in the real world, and we ended up with something that does. We just created stuff. Yeah, we went from imaginary stuff to real stuff. Somewhere in the universe, a black hole was just created. Right there. What's up?
Where did you get the
Where did this one come from? So do you see that I got a remainder of 0? And the remainder corresponds to the exponent on I. So remainder of 0 means I to the 0, but what is anything to the 0? 1, and that's where the 1 comes from. So I to the 4th power is really just 1. I for imaginary, yeah, that's right. And not some other letter. Y'all still want to play the what if game again?
So, if it's imaginary, why do we need it?
Because these things come up in different fields. Like in the field of electronics, when you're calculating circuits and stuff in electronics, on occasion you come up with imaginary numbers. Now, why do you specifically need to know it? You probably don't, okay? But there are places that this stuff comes up when you're doing calculations. But as far as most of you, I don't think I've ever used imaginary numbers outside of my job. You know, I've never been shopping at Walmart and thinking, I'm glad I know how to do imaginary numbers, you know, because I got to buy toilet paper and never mind. Yeah. Now can I move on to the next section? Are y'all tired of playing the what if game on that? I am.
We're interested in imaginary numbers.
No, I'm just making sure I understand.
Yeah. Now, did y'all know that you can submit problems to me and I'll work them out for you? Did y'all know you can do that? So if you run into a scenario or a situation later and you're going, well, he didn't show me how to do this, just send it to me. I'll explain it. I may turn it into a YouTube video. All right, what's the next section we need to cover? 7.4. And if you have a book and want to join me, I'm going to be on page 477. Am I going to see y'all tomorrow? Okay. So this section is on quadratic equations, functions. It says zeros and models, but we're just going to title it that, okay? Quadratic equations and functions. Have we talked about quadratics in here before? Y'all know that to be quadratic, it has to have an x squared and not anything bigger like x to the third, fourth, fifth. Okay, so let's start with some notes. We actually need to start with some notes here. Anybody seen that before? Yeah, so this is called the standard form of a quadratic equation. That is the standard form. And I think most of y'all are familiar with this form because you've seen the quadratic formula, right? And you have to know A, B, and C to plug into the quadratic formula. And so this comes in handy, okay? So this is standard form. There is another form. Yeah, there's another form of a quadratic equation. And this one is called vertex form. Now, do y'all know what shape a quadratic equation produces? What is the shape of the graph of a quadratic? Parabola? And does everybody know that a parabola has a vertex? The lowest point? Or if it's upside down, the highest point? So we're calling this vertex form because the ordered pair h comma k is the vertex. The vertex is the point on the parabola that's either at the lowest point or at the highest point. And that turns out to be real important when you're talking about finding the range of a quadratic. Remember, the range is from bottom to top? And so the knowing the vertex, real important to getting the range of a quadratic. Okay, so let's talk about, let me look at my notes real quick before I go on. Okay, let's talk about ways to solve. How can we solve a quadratic equation? Well, we may have already done some of these. Have we covered factoring in this class? How to factor the difference of squares? How to factor trinomials? Okay, so one of the ways that you can solve a quadratic, and probably the easiest way, is to solve by factoring. But does everything factor? Or are there some things that won't factor? And so we need other techniques. So technique number 2 is the quadratic formula. And there is a third technique that they're going to ask me to cover, which is called completing the square. And so we're going to look at all of these strategies for how to solve a quadratic equation. These are all useful. Yeah, and before I go into doing examples, I think we should write the quadratic formula. Does everybody have that memorized? Everybody have the quadratic formula memorized? No? Okay, well, I'm going to give it to you in song. So I'll help you memorize it, okay? I'm going to give you the quadratic formula song. Are you ready? Okay, here it goes. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Anybody ever heard that before? Quadratic formula song? Y'all write it down. We'll sing it again together, okay? Y'all really should learn that. Well, who said what? I know. Because at Christmas, when it gets closer to Christmas, we'll go around to all the other classrooms and we'll sing it to Christmas tunes. We'll go Christmas caroling. Quadratic formula.
I'll wake my kids
Yeah, keep trying. All right, so now that you've got it written down, let's go through again and let's sing it again so you can learn the song, okay? Ready? Here we go. X is equal to negative b plus or minus the square root of b squared minus 4ac. There you go. Way to finish strong. Way to finish strong. Y'all recognize the tune?
Yes.
What's the tune?
It makes
Oh, it's the pop
Yeah.
box.
Like a Jack in the Box?
What is it? Pop Go the Weasel? Yeah. Yeah, it goes to other tunes too. Anybody got a birthday coming up or had a birthday recently? Yeah, watch this. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Happy birthday to you. How about Smells Like Teen Spirit? Yeah, it goes good to that too. It does. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Yeah. There you go. Awesome. And that's all recorded. Y'all want to go hear that again? It'll be on YouTube. All right, so I got about 10 minutes left. Let's look at some examples. Starting with number 1. Now we're actually doing some problems. And we're going to start with the easiest problem I can think of. And that's the easiest quadratic. So notice that this problem is already equal to 0, which I don't know if you noticed, but standard form says it has to be equal to 0. And did you notice that it's already factored? So all we have to do to solve this problem is set each factor equal to 0. This quadratic is already factored. And since it's equal to 0, we can just set each factor equal to 0. So we're going to move the minus 3 over and then divide by 2. So one of my answers is 3 over 2. And for the other factor, we're going to move the minus 2 over and divide by 3. And if we want, we can see that. Anybody have any questions about that? Y'all have any questions about that? Nobody? Heck yeah. Number 3. Now, of course, we're going to step it up a notch for the next one. Do you see that this problem is equal to 0, which is important, right? It needs to be equal to 0 if it's quadratic, but it's not factored. Let's try to factor it. If we can get it factored, we can work it the same as we did number 1. Okay, so can you read the signs? Negative, positive, right? Minus at the back makes them different. X and X, And the numbers?
2 and 10.
Now which one goes where?
2 is with the positive and 10 is with the negative.
And do y'all understand that it does make a difference where you put the numbers? So positive 2 minus 10, that does make minus 8. And we know we have them in the right place. And so now we can set each factor equal to 0. And so moving the 2 over and moving the minus 10 over. And how many answers did we get? And how many answers on the previous one? And does every quadratic have 2 solutions? Yes, it does. Oh, yes. Every quadratic has 2 solutions. Does every quadratic have 2 solutions? Yes, it does. Y'all want to do another one? You do? Yes. All right, can I make it up? Oh, thanks. I got a special one. This one is just for Rachel. Now, does that problem look a lot like the one we just did? Is it equal to 0? Is it factored? No, but I think we can factor it because it is a standard trinomial. What are the signs going to be? Yeah. Both negative. X and X. 9 and 9. Now, do y'all notice that those factors are identical? So do I have to set them both equal to 0? No, but if I did, I get the same number, right? So in this case, we're only going to get x equal 9. But do you understand that that really is 2 solutions? They just happen to be the same this time. That's like if a woman gives birth to identical twins. There's still 2 of them, right? Even though they look the same. Don't you tell her she didn't give birth to only one. She can say, oh, I squirted 2 of them out. Yeah, so there are 2 solutions here. They just happen to be the same, okay?
It was with something else where there could be no solution and or one of those 2 solutions would work.
That will never happen in a quadratic.
Then it was like something else that I was
Okay, yeah, that was when a quadratic comes up in a radical equation. Yeah. And those you do have to check. Let's see. Okay, I got another one, number 15.
You have to set that to 0, don't you?
Right. And so do y'all see each one I do, ever so often we crank it up a notch, right? And so notice that this is quadratic, but it's not equal to 0. You got to equal it to 0, so the 6x needs to move over. Don't forget that he has to become negative when you move him over. And now notice that there's not 3 terms, there's only 2 terms. So how do I factor that? I'm hearing somebody say 2x. Do you mean that I can take out a 2x? Okay, so let's factor out a 2x. And if I factor out a 2x, what will that leave me with? X minus what? Yeah, Choppa throwing it down like a gang symbol. Yeah. And now that it's factored, we're going to set each factor equal to 0. Now for the first factor, we're going to have to divide by 2. What is 0 divided by anything?
It's not imaginary.
I thought I heard 1. I think I almost passed out. So again, 0 divided by anything is 0. And y'all know that's not really true. There is one number you cannot divide 0 by. 0, yeah. Because 0 on the bottom is undefined, right? Okay. And then on the other factor, we're going to move the minus 3 over. Oh, and look at that. I get 2 answers again. Every quadratic has 2 solutions. Do y'all have any questions so far? Nobody?
When would you use the quadratic?
Okay. The question was, when would you use the quadratic formula? And the answer to that is, if it won't factor. If you set it equal to 0 and you can't make it factor, then the quadratic formula is a nice tool. But to answer your question a little more broadly, you can always use the quadratic formula. So on this problem, if I didn't want to factor it, I can say, well, A is 1, B is negative 18, C is 81, and I can plug into the quadratic formula, and I'll get this answer. Do you need me to show you? I think I will. And it's getting real close to when I wanted to shut this thing down today. So the last thing I'm going to do today is I'm going to just barely dip my toe into the quadratic formula. We're going to go back and we're going to do this problem I did here. We already know what the answer is, right? But we're going to work it with the quadratic formula and see if we get the same answer. So A is 1. B is negative 18. And C is 81. Do y'all see where I get those from? Right? The coefficient of x squared is A, and then B, and then C. And now I need you to all sing with me, okay? X is equal to negative B plus or minus the square root of B squared minus 4AC. Okay, y'all might need to work on that just a bit. Put more into it. All over 2A. With emphasis. Now, with your calculator, I need you to calculate the radicand. Do y'all remember the word radicand means stuff under the radical? I need you to calculate negative 18 squared minus 4 times 1 times 81. And don't forget that negative numbers have to go in parentheses. Does all of that work out to just be 0? Okay, Mina's doing it too, I see. Anybody else pushing the buttons out there? Brittany, you got 0? Oh, we got verification. So if you calculate this stuff under the radical, if you do it all at one time, it gives 0. But what is the square? Huh? You got 2? I'm going to have to come look at that. Oh, you did the square root. We want to just do the stuff under the square root, not the, don't push the square root button. Just the stuff under the square root. Now, what is the square root of 0? What? 0. Okay, so look at this. This piece basically goes away. And the only thing that I'm left with is 18 over 2, which is 9, which verifies the answer we got. If the stuff under the square root becomes 0, then that whole thing disappears and you're just left with the 18. 18 over 2 is 9. And so the quadratic formula will work every time, even if it factors, okay? But especially if it doesn't, you want to use the quadratic formula. Got that? And what we're going to do next time is we're going to pick up where we left off. I didn't finish this section. So we'll pick up where we left off, okay?